I am pleased to be joined today by David Safrinko and Lynn Register. Before we get started, I'm just going to run through really quickly. If you have any questions, please write them in the question box on your GoToWebinar box. I will either address them if I feel they are something that needs to be addressed immediately. Otherwise, we will just push to the end and have a Q&A session. So without further ado, I'm going to let Dave get started. Dave, take it away.
Hi. Thanks, Brian. Again, good afternoon. As Brian mentioned, I am Dave Safrinko. I am the testing practice leader for DISYS. And again, accompanying me is Lynn Register, who also has 30 years experience in the financial industry. I asked Lynn to join us today to expand on any of the topics we're going to be recovering as we go through, and of course, she's available to answer any questions. Lynn is currently managing an ALS testing effort for a major bank here in the Southeast. So very quickly, our agenda, I'll go through real quick. Introductions we've just had. We'll go over a little bit about some financial applications and then go into some business process modeling, risk management, data management, integrated test environments, cloud management, test workflow, and then we'll end on test automation. So banking applications, again, are considered to be one of the most complex applications to today's software development and testing industry. Some of the contributing factors include the multi-tier architectures and technologies, the large-scale integrations, again, internal and external third-party interfaces such as bill pay, CMS, card management systems, credit and risk systems, and again, there's many more that go along with that. Additionally, complex business rules and workflows, again, from an end-to-end perspective, real-time and batch processing, high rate of concurrent users and transactions, and of course, we have to manage the secure transactions, reporting requirements, multiple data sources, and of course, all of our finance have regulatory compliance issues. So just taking all these factors into consideration, accommodating and testing the variations in workflows, is a daunting task. Specifically, if there's any kind of constraints we encounter or inefficient planning. Applications, again, this is very quickly looking at a typical online banking infrastructure. You can see there's multi-tier processing is involved from most of those operations. Again, from online banking, just a few are the end user and browser interactions. And again, it's not only browser, but it's multiple browsers. And of course, accommodating the security that goes along with those browsers. Mobility testing, SOA architecture, data validations and endpoints. Again, various data sources, procedures, and of course, transaction processing, which is integrated with, in most cases, mainframes or legacy systems, subsystems, or interfaces. So to assist and manage those complexities, our experiences is incorporating end-to-end testing with risk management techniques. It helps ensure thorough and complete testing and coverage of the requirements. Again, these techniques and experiences over time, we do leverage business process modeling, incorporating the risk-based testing approach, of course, having a sound data management strategy, environment management strategy, and then to provide some of those capabilities as we go through, we'll understand how we can leverage cloud capabilities to help us test, and of course, back to test automation and accelerators. So we go through business process modeling. So there's a picture over there on the left that shows some of the complexities of the components that make up a complete process. Again, we focus on end-to-end processing, but by virtue of our component by component, we not only test at component level, but really the goal of this is to test it from an end-to-end user input to actual writing of the database. The process models, again, assist test engineers to understand the testing from a holistic and visual representations of the complete system goes a long way to clarifying requirements. Secondly, again, it's combining those multi or multiple components at the level, component level test to understand the integrations between components as well as the data and business roles. So again, we do focus on an end-to-end processing, and one complete process from end to end is one business process. So looking at that model over on the left, you can see there could be, I couldn't tell you, I didn't count them, but you're looking at maybe 20 different business processes with this one particular process model. Other benefits, again, the QA engineers can view and analyze the requirements in one complete end-to-end versus having to page through multiple requirements documents. So typically we're going to get a functional overview document or a business requirements document, specifications, whatever you call them. Then you have to couple them with the architectural requirements and the integration requirements. Just looking at a process model, we can holistically clarify and understand the entire system that we are testing. Secondly, we've encountered or experienced is that once we create these process models and go back to the business, it's the first time the business can understand what they're asking to be built. And we actually validate these processes with the line of business, and it really helps clarify for them, is it really what they want to be, is this really what they want to be built? So it not only helps the QA engineers, but also from the line of business perspective. Also from the business process model, we can easily and quickly identify data and control paths to assist, again, the QA engineers and the data management people to capture data requirements. Obviously, all these components are sequential in nature. And another viewpoint that's not on here is if there's a particular defect in any one of these processes, you can quickly isolate that defect and determine the upstream and downstream impacts of a particular defect. Also, BPMs, process models that we create, coupled with our automation framework here at DISYS, we automatically can generate the manual test cases. So from an efficiency standpoint, leveraging our framework, we can generate once we validate the business process model by a simple click of a button, we can generate all of the test cases that are associated with this model and then automatically import them directly back into the Quality Center or TFS. So it has multiple uses. Again, if you're familiar with Agile or UML in the past, we are simply just creating these process models as a matter of clarifications and really from a planning standpoint to help QA create their strategies and master test plans and really validate the system from the business perspective. Risk management. So we conduct the risk management for all of our engagements. We can ensure during any time constraints or resource constraints, we are testing the most critical functions first. So we consider the risk management upfront due diligence to ensure we identify all critical operating issues or key process areas. So again, in those events of time constraints or resource constraints, we are testing the most critical functions. Over on the right-hand side of the presentation, you can see the criterion we use to assess those risk factors. These are pretty industry standard: frequency of usage of the functions, complexity of components where probability of failure is high, component or systems with 3 or more integration points. And really what I focus on is component systems or processes identified as critical to effective and efficient operation. And I further clarify that is if there is a defect discovered in production, that particular function or defect would warrant a severity 1 or 2 status. By identifying those up front at the requirements as well as the business process level, we automatically put those into our regression test suite, and subsequently they become automatic automation candidates if you understand those are critical. And of course, the last piece of our risk management deals with anything that deals with governance, anything on the anti-money laundering, SOX, audit. So all those things are taken into consideration. So there is 5 steps to our risk management. Is we identify those risks, come up with a strategy to understand them. do the assessment on the probability and also clarify whether they're high impact or low impact or probability. Then, of course, come up with a mitigation strategy. And then as for everything else, we do the analysis and reporting to our leaders and management so they understand as going forward the different types of risks that are within this particular project and how we are mitigating them, tracking and monitoring throughout the duration of the project. So again, the whole purpose of the risk-based approach is really to assure the client's most critical functions are thoroughly tested during time constraints. Data management. So we're testing financial applications. We must all agree they are data hungry. So again, many permutations and variables are within all these applications, as well as the business rules that are applicable to the workflows. The input of the data types determine the behavior of the system and subsystems, and having a good data management plan or strategy to accommodate all of those particular test cases is a huge part of the testing, pre-planning, and planning effort, as well as very time-consuming when doing that data mining and conditioning. So during the test planning, we need to ensure, we cover all the scenarios as well as condition the data to drive errors and exceptions. So we actually, in our framework, do have two that I presented up here as the data prioritization workflow. So again, being SOX compliant from a financial aspect is mandatory. How we implement those SOX controls varies from bank to bank, institution to institution, but we do have a process where we can scrub that production data and then, of course, make it SOX compliant, so we have no risk of data compromise. Secondly, over on the data extraction, the data permutations as well as the data mining and conditioning, we do have a process there as well. And again, so we can take that production data, scrub it, and then put that data into multiple test environments. The big thing here is we've encountered with many corporations is the ability to refresh that data. So in most instances, we have to plan accordingly, do those data refreshes, and in some areas where we have done some efforts, it can take up to a few days to do that. And again, this is due to multiple data sources, as well as the data must be refreshed proportionately throughout all of the data sources. For those that are leveraging mainframes and even down to non-relational databases such as DSAM files, etc., it becomes a huge task to ensure that if we are scrubbing data in one database, we must scrub it like in all the other data sources for our test to work. Otherwise, we are going to be getting a lot of data conflict. Also, from a data management perspective, it is very common to have data conflicts. So when we have multiple testers out there doing data, it's really using that same data source as they construct their test. When they're executing it, we will have data conflict. So, for instance, if we create a script to do a withdrawal from a particular DDA account, my tester sitting next to me may have a test to wipe out that account. So when I execute my test, those funds are no longer available and the test is going to fail due to insufficient funds. So having a data strategy that's going to plan well that the data that's in use or test data goes a long way to not only ensure your tests are actually executable, but if the tests fail, the troubleshooting you're going to go through, it may come down to a data issue. In our particular workflow, once our testers extract that data and tag it to an automation or a manual test case, we actually lock that data or that record. That way, when the next person goes out and does a query to mine data, that data doesn't even appear to them. And that way, we could limit any kind of data conflict as we continue to create the data set that's respective to the particular test we are executing. So a good data management plan should cover, what one tester does and ensure that we don't select the same data or, being able to modify data that we've already planned to have in our test. Before we go forward, Brian, is there any questions?
I was muted. Not at the moment. Keep going.
Okay. So integrated test environments. Again, in most cases, financial systems and banks leverage mainframes. Duplicating or replicating production-like systems is extremely expensive and often not sized appropriately. And then, of course, to ensure test integrity and SOC compliance, the test environment should be restricted to QA personnel. So an integrated test environment, really the purpose is to provide quality assurance and test engineers a segregated, independent, and restricted test environment to plan, execute, and report test findings and metrics about the application of the test. And then using that in conjunction with your QA policy, standards, procedures, we are able to, again, maintain that test integrity as we go forward, as well as ensure we are compliant with any regulatory governance requirements, again, mainly back to SOX. Our integrated test environments is multiple components. You can see we have the environments manager, the release manager, data privacy, the software configuration management, test management. All those particular functions work together to ensure that, again, the environment in which we are testing on is representative of the production environment. Of course, on FCM or software configuration management, they track the code as it goes from environment to environment. Release engineering to ensure that what we are testing is what's being deployed into production, as well as the test automation and environment management to ensure our configurations are controlled. So integrated test environments, again, an ITE strategy will have multiple yet distinct environments necessary to conduct all phases of tests. Each environment needs to be configured as close to production-like as feasible to include middle-tier configurations as well as core legacy third-party interfaces. And of course, it's all populated with production-like data. At the best case, that production-like data is not, it should be scrubbed to make it SOC compliant, as well, again, to minimize any risk of data compromise. And the last, intended to configure the ITE to the maximum extent possible like the existing production environment. And that, again, all that is necessary to ensure verification and validation of the applications under test are commensurate and representative of production behavior. So this is a particular ITE conceptual diagram. Again, you can see all of the components and platforms and operating systems and databases. It's a huge effort, and this particular picture here is a small sample. But if you look at the amount of test phases that we go through, there's really 7. And some can have more, some can have less. But typically you have your SIT environment, which is really a development environment to test the integrations. System functional, then regression, user acceptance, pre-production, performance, and break-fix. Break-fix environment is really to test production defects. Again, it's a fast track, which I have a diagram in the next. But again, the key component here is we want to test end-to-end with the system integration, third-party interfaces. And of course, a key component of this is having a software configuration management plan that tracks all the code as it comes from the source repositories through the various environments, keeping them all in sync, and ensuring again that what we are testing is the intended target in production. So code promotion paths. You see over on the left-hand side is development environment. As the developers are working, they check that code into the software configuration management. That is either a person, system, or a combination of both, which of course will then ensure all the associated or support code is all assembled. And of course it is sent concurrently, and again this is optional, but typically we send it to our system test environment and the performance test environment as well. So those go on concurrently because we really in the past performance testing was done at the end of the cycle, and it's kind of late in the development cycle to get to your performance test environment and find out that it's not performing and requires some rework, which then again nullifies that functional test, and we start the process all over again. So if available, we deploy it to both test environments at the same time and doing the performance test as much as we can, and of course the system test is where all the functional test is taking place. The break-fix environment you can see in the red is, we call it fast track, so if there is a production defect, it doesn't have to follow the normal code promotion path. We send it directly to that break-fix test environment to validate the fix and send it directly into production. So the ITE, again, certainly benefits testing perspective because, as we all know, the system test environment and the regression and user acceptance, all the tests have different focuses. The system test is generally 100% of the requirements coverage. When it moves over to regression test, that's really where automation is going to pick up, as well as it's focused on the most critical functions. Industry says that is typically 65% of the system test space. So if there's 1,000 in the system test, regression test should be somewhere around 65, 650. And then, of course, user acceptance tests, I typically do not script those. Really, our guidance is for the end user to do their daily routines in that environment to ensure from a UI perspective, as well as understanding from a user perspective, they can go ahead and use that environment to do their testing. And of course, once everything is accepted, it will then be promoted back into production. So due to the cost of all these tests, especially when we get into mainframe, sometimes it's not feasible to have to build or replicate or duplicate all of these test environments. Depending upon what resources are available, the performance test environment is where we would recommend you build first, because that particular environment can accommodate all test phases. Performance tests should be no less than 80% of production. Anything less than 80%, the industry tells us you cannot extrapolate those performance numbers. It comes down to CPU utilization, all those things that go into play for an extrapolation. Anything less than 80%. System tests, regression tests, user acceptance tests, those environments can be scaled down since they are functional versus performance, which is really the most production-like system, depending upon the amount of resources and dollars and everything else that goes along with building these environments. So to accommodate that with the advent of the cloud and all of, everyone's talking about the cloud, from that particular standpoint, the system, regression, user acceptance, and break fix, it may be possible, depending upon your organization, to leverage the cloud to create those particular test environments, especially if your data is SOX compliant. There's a minimal risk. And since, again, we are doing those functional tests, it's permissible to use the cloud or virtualization of a production environment to do that functional testing. But you can see here I left production and performance as standalone. So, again, we want to make sure we're using representative hardware, software, etc. And, again, keep that performance for the representative of production behaviors, where the cloud capability can certainly accommodate all of your functional testing. So when we get into cloud management, cloud benefits your testing capabilities. One, because zero upfront investment. It's also on-demand provisioning. So as we know, the cloud offers the ability to spin up these clouds with your particular infrastructure and environments and OSs. And then once you've done testing, you can quickly remove those. And again, not only with the instant automatic scalability as far as adding additional capabilities to that infrastructure, but it's also pay as you go. So if your test lasts 3 days, that's all you're going to pay for. You simply spin it up on demand, and then when you're done with it, you spin it down, and you'll get a bill monthly from whoever for only the amount of time you're actually using that infrastructure. DISYS, by the way, does have a product called Zero. It is an award-winning product that we've built that allows us to customize and spin up these test environments, tracking, and of course cleans up. And of course, it is customizable for role-based testing, which is critical, as we all know, in the financial industry. Lots of roles on who can do what, especially from a finance perspective, from a teller to a loan officer, etc. Although it's all one system, having that role-based capability or testing requirements is critical to ensure we test 100% of the coverage. From the functional testing, again, having this ability to do on demand, we can quickly create those smoke test environments, system test environments, regression, UAT. You can also, again, these are just limited what I've put in the presentation, but you can also spin up your training environment. Anything that goes along with that you really don't need the representative hardware, software, and servers that are associated with production, you can actually get all those capabilities by leveraging the cloud. So from a test workflow perspective, again, what we do from a testing perspective is all around requirements management. Our first phase of test is always to scrub the requirements, ensure they're testable and measurable. Again, from that, we would create your test strategy, project plan. As important is your resource plan as well as your budget that goes along with it. From that, and you can kind of mix and match this to do a risk analysis first to identify out of those requirements your critical operating issues, key process areas, your governance and regulatory items, and then create your business process models, or I particularly do the business process modeling first, and from that I will work with the line of business to determine which one of those processes are indeed have those critical operating issues and create that way. Then you can see once we do that coupled with our design, that is the what. That really determines the scope of the entire effort. And doing those indicators on your process models, you can quickly do the system test because that is 100% of your requirements. Your regression, by putting those indicators from your risk analysis on the COIs and KPAs, those automatically become part of my regression suite, as well as they become part of my automation candidates. And of course, going through and identifying all those process flows, you can quickly put an indicator on there whether it's a performance test requirement. So by taking those requirements, understanding the requirements from an end-to-end perspective, coupled with the design document coming from development, we can just, by virtue of doing the reviews and the upfront due diligence, we can create those 3 test folders on the right-hand side. And of course, from those, create your master test plan, the requirements traceability matrix, your data management plan, environment management plan, and of course, your test automation strategy. Again, the sheer number of test cases, especially coupled with the amount of data that's necessary to do a happy path as well as drive those error routines. And then, of course, coupled with milestones and timelines, it mandates the need to leverage test automation. This particular slide here is showing our HP stack, leveraging Quality Center, ALM. On the left side, it's also incorporated with Visual Studio and IIF. Everything is seamless, integrated, and of course, very efficient. On the right-hand side, when we're working with clients, especially banks with the CICS and AS400s or any type of green screen, we do leverage the CompuWare Suite file and Easy Tree to extract those mainframe data sources and bring them into a relational database where we can do all the testing about that. Even back to green screen, doing either the screen scraping or using the coordinates, DSM files and copybooks, etc. So we have two frameworks that allow us to do that. Although this is based upon HP, we do support TFS, our Team Foundation Server, and Visual Studio ESTS, as well as for the companies that are looking more towards an open source solution. We do also work with a lot of Selenium, people who've incorporated Selenium into this. So we're very tool agnostic, but from a DISYS perspective, these are the frameworks that we leverage as we go through and automate. So as we go through, there's typically 4 automation frameworks out there: data-driven, keyword-driven, modularity-driven, and hybrid. We do not take a single approach to anything. We really evaluate the application under test and the technology. And not only do we not use any particular one, but most likely we'll use a combination of all of them. So especially in the finance market with the amount of data and permutations, we use data-driven. Again, input data will determine the output or the behavior of the system. Keyword-driven, we use this a lot as well. And again, it's just the way we organize our test cases in the repositories. Modularity-driven is we use this quite extensively, especially due to third-party interface testing. So as we test a integration point with either Fiserv or TSYS or some other one, not always will those particular third parties give us access to their test environment. So the usual solution would be to stub out those records. Modularity takes that a little bit further, where we actually build some logic into our module, and it really simulates or emulates a Fiserv connection or a TSYS connection. So we do use the modularity-driven testing quite well. And then, of course, the hybrid, which will take part of the not keyword data-driven and modularity. And again, we don't focus on any one. We select which test or which framework is best suited to meet obviously the end goal and need. And by the way, all these things are integrated into a single framework. It's just, these are techniques within our framework. Test accelerators. So from an efficiency standpoint, test accelerators, help speed up our testing requirements or the tasks that are associated with each one of the tests. Going from left to right, the process modeler, and we talked a little bit about that earlier, business process modeling. So we created a framework where by leveraging Microsoft Visio, we can create a business process end-to-end, all the components. And again, of course, we read that into our framework here. And then once we validate that with the business, we can go ahead and, like I said, click a button, and it's going to automatically generate all of the test cases for us. And then, again, you can export directly into Excel or load directly into Quality Center or ALM. So, again, this is very efficient and effective. It really minimizes the need for manual testers to sit there and create these manual test cases based on Word documents. By leveraging the other benefits of leveraging business process models and our ability to generate the manual test cases really helps us provide the most cost-efficient and effective automation solution. Second one is a data validation. This is where with each one of those components, it will bring up a properties file, and from that we can generate or create all the business rules that are associated by components. Again, as a one-to-one, many-to-many relationship. Then, of course, we would execute those roles using multi-threaded execution engines. Third one is really to help us with the data explorer. So again, we recognize not all manual testers have skill sets, so we created this particular accelerator that will connect through all the data sources, either through ODBC or JDBC, and it will actually bring up all the data elements within that data set. And by virtue of clicking boxes to select your data, this particular accelerator will automatically generate the SQL statement. So once we create that as a stored procedure, the particular or the respective test engineer will go ahead and click. It'll bring back all the associated data. And once he selects that data, like I said a little bit earlier, we lock that record so it will never come up again when somebody is using data mining, looking for test data. You can also customize the data in here to throw exceptions and validate error routines. There is also a web-enabled, so you can access that through the web as well. The fourth one is a data validation accelerator. This here is actually a picture of a copybook. So those that are having the mainframes, and again, whether they're SAM or relational databases on the mainframe, doesn't matter. We can actually extract by using easy trees and file aid all of those copybooks and bring them into our framework. And from that, we can do all the manipulations and testing on the mainframe data. And then once we do the testing, obviously it goes back into the mainframe. So it's very efficient. Coupling all four of these tools, again, about not only being efficient in our processes, but it allows us to do all of the data permutations that are respective of the financial application. In addition to all of those capabilities, our automation framework does provide a single consolidated view of all relevant data and the base decisions. What's unique about this is if you're using multiple tools, again, like either Quality Center, and you can incorporate that with, say, Informatica or, Excel, CompuWare suite of tools. We integrate all that, extract that data, and present them in a single consolidated dashboard. It's also customizable. We can build anything and everything as long as we capture the data sources, and they're dynamic. So these are on-demand, ad hoc, and again, having that one view versus having to go into multiple data sources, try to come up with a decision. We took all of that and combined it into a single data source. And of course, clicking on any one of those pie charts right there will keep drilling down till you get to the actual data, so you can see, depending on who's viewing these, whether you're a manager to want to see what part of those thread or defects, what test cases they are, or if you're a senior leader, you're just going to look at their own perspective. So again, totally customizable, dynamic, and on demand. The last thing we want to go over is the automation estimation. So this is really core of our particular business, where we break down or give estimates in the ROI. So we obviously look at the manual test cases. Again, this particular thing on the left, one particular financial institution we worked with had 15,000 test cases. Estimation at the 65% came down to 9,750. And then we break those down into test steps. Each step is broken down into average of 1 to 15 simple, 16 to 30 for medium, and 30 plus for complex. And then we base it upon an average. Secondly, what we look at here, I just circled it there, is the percent breakup. So out of that 9,750, we thought the breakup per simple would be 50% of those would be simple, 30% would be medium, and 20% would be complex. And then our productivity steps during the day, it's all calculated in dynamic here to give us the person, day, and week, and month. So you can see this particular effort down the bottom are the associated tasks, which is setting up the infrastructure or the automation framework. Then, of course, scripting and testing the components, the simple, medium, and complex. And at the end, it comes down to what the person, month, week, and days are. So over on the upper right-hand side, you can see what it takes in minutes from a manual perspective versus a automation perspective. In this particular case, it took us 6 months to develop all of the test, the suites, and the automation. I can tell you this effort here was 32 contractors that were doing it. The regression test was taking nearly 20 days. This was a mainframe of batch processing, by the way. And over that period of time, to keep filling these regression suites with the 32 contractors, it was $264,000. After we automated it, we were able to get that down to 5 days at a cost of $18,600. So the initial investment in the ROI, you can see the break-even point was after the 4 point some times that you would have got your ROI back on automation. So again, the variables here are the percent breakup of the single, medium, and complex. Some organizations who are more complex, obviously those numbers are going to change. You can put 50 instead of 20, and it would, all these numbers would readjust itself. And of course, the amount of test cases is what matters. But this is the largest effort we did by far, essentially taking from 20 to 5 days, but from 260,000 down to 18,000 for running regression cases. The last slide here is on knowledge and supporting technologies. You can see we have vast experiences with financial and banking companies. These are some of the products we work with. The main ones here is Fiserv, Fidelity, but of course we support everything, you know, from Linux, AIX, to Green Screen, to OS 390s, Jack Henry, NCR, Oracle. And then down the bottom, some of the applications we're working with, especially from the Fidelity suite, the ALS, Impacts, GL, CL, as well as some of those other ones. Even down to change management, control M for your schedulers, etc. So these are some of the technologies and products that we are currently testing, or in the past have tested, and have knowledge as we go through and taking on these testing engagements. And the last slide is questions. So back to you, Mr. Bryan.
All right, Dave. So anyone has any questions, they can just type it into the question box. There are a couple that have come in. I just want to give everyone a chance to do so. First question, Dave. So going back to when you were talking about the benefits of Zero, what benefits does Zero provide in a testing environment that would not be recognized typically?
I'm not sure I understand the question. What Zero does, it's a profiler that we can type into Zero what their infrastructure is, what their operating system is, database, etc. And then once we create that profile, we can click a button. And by the way, Zero and DISYS is partnered with Amazon Web Services. So we send that request up to Amazon, and Amazon would build that infrastructure for us. And of course, we would test hitting that infrastructure in the cloud. So I'm not sure. So after we're done with that particular test, the test lasts 3 days. We would use Zero to break that down, and Zero would do the tracking as far as time goes, how much utilization we use, that type of thing. And that's only the amount you will pay for. And again, if you push that against trying to build out a banking infrastructure with all those components, you can see it'll save, you know, literally hundreds of thousands of dollars.
Okay, thanks, Dave. I don't have any other questions that have come in thus far. Actually, whoop, one just came in. Can you please repeat the industry standard and performance tests and automation tests?
Okay, so from a performance perspective, what the industry recommends is when you create a performance test environment, it should not be less than 80% of production. That's typically, they say, once you get less than 60%, when you extrapolate, it may not be it may not give you the exact behaviors you're expecting as if you were over the 80%. So we try to do that. So other thing what people try to do is they'll take the performance environment and they'll size it proportionally, say make it 25%, only 25% of the production data in there, and again, think that's okay. Industry clearly says that, again, it's not a one-for-one. It doesn't quite work that way, and you try to extrapolate. That's what they recommend is building that performance out at 80%, no less than 80% of production. That includes CPU, like hardware, as well as the associated data that's in production. The second thing is on the automation. Typically, what the industry is saying is regression based upon the critical components of any system. It's typically around 65% of your system. So system obviously is 100% test coverage, and that includes all the bells and whistles, all the everything that goes along with it. When you are under time constraints, if you have a defect or a production defect, you don't want to have to execute a system test that's essentially going to take you 3 weeks. You want to execute your regression test. And those regression tests are really those critical functions that, if sent into production, they can still effectively do their job. That percentage is typically 65%. So if you have 1,000 test cases, your regression test will be somewhere around 650. Out of that 650, DISYS' goal is 85% of that 650 will be automation, will be automated. There are some things that we're still not going to automate, some things can't be automated, some don't make sense. So we will do a feasibility study on that, but typically your regression suite is going to be 65% of production, and out of that, at least 85% of your regression suite should be automated.
Okay, thanks, Dave. Next question coming through. What are your thoughts on using, I'm not familiar with this term, LISA, simulating a test environment?
Sure. So LISA is a great tool. LISA can be used, LISA is a test tool to begin with. But secondly, how we try to leverage LISA for these people is up in the cloud. So LISA allows us to capture those request response simulating mainframes. So you can actually virtualize the mainframe up in the cloud. Otherwise, LISA is a great tool. It's very popular. We've incorporated LISA at 2 banks that I know of. And again, it's a good tool. It's CA now. And again, part of our cloud solution from a mainframe perspective is to leverage LISA to provide that request response. But otherwise, as a tool itself, it's also very robust and capable of testing end-to-end, much like a HPC.
Okay, thank you. Next one through. Normally the cost of maintaining test environments is high. We do not use separate environments for SIT and system tests for regression. What is your business case for separate regression environment?
Well, 2 things. One, system, again, is 100%. Once you, SIT, by the way, is a development environment. If we're following the SOX rules, there is no communication link between the ITE and SIT. The SIT is development, and as we all know, SIT developers cannot have access into the ITE because that's a SOX compliance issue. So SIT sits all by itself. It sits over on development, and they kind of manage that themselves. On system environment, it's more of we are doing 100% in system. When we take that and move it over to regression, I can technically take the next build into system and keep those things separate. So I'm running all of my automation in regression. My SIT could be build +1 at this particular point in time. You can, again, depending upon resources, you can, if need be, use the SIT for regression. But what that means is you are essentially taking that system over from a regression perspective because you don't want to mix and match code versions. It's not as efficient having these separate ones, because as soon as I move into regression, I can take the next build into system and do my functional testing. For automation, it's going to be running in my regression.
Okay, I think that hit on it pretty well. If there are any other questions, I'll give it just a couple seconds here for any to come through. So I think that's about it, Dave. Thank you, everyone, for joining us today. If you have any questions or comments for Dave, we will be sending out a follow-up email tomorrow. This will include a way to reach out to us for any questions or if you want a copy of the presentation. We will also be sending out a link that will have the recorded presentation for your reference. So Dave, thanks so much for everything, and thank you everyone again for joining us.